Rescue Global is a UK charity in the US, not-for-profit. We used to specialise purely in search and rescue, and then very quickly we found that one of the biggest problems in the humanitarian disaster response community was the need for credible, accurate, timely information to plan missions, be it search and rescue, be it delivering aid all different parts of the world. So take, for example, Super Typhoon Haiyan, locally known as Yolanda, a few years ago in the Philippines. The people who were meant to be responding to that were the NDMA or the NDRMC, the host nation of that country. They couldn't because they didn't have any information. We know what information we need to gather, where people are, what they need, so needs-based data. We know who needs it, the host nations, the government, the NDMA, and secondary actors like the humanitarian community. We thought, how would we gather that? And some of it would be using the kind of techniques you'd see in the military, like reconnaissance, or in the fire service, the first fire engines that turn up on an event. So it's not that difficult to gather that information, but then what the real challenge became, which is where big data comes in, is how much is too much and how much is enough.
So Rescue Global's been working with BMT and with Oxford University on this proof of concept project, which has been really exciting. I think each of the three partners have brought something quite different to it. So the thing that we were very excited about in this project is the potential to look at what a crowd-sourced assessment of data could do in order to speed up our own decision making and to create intelligence that's actionable, so that's accurate, that's rapid, and something that our teams could be using when they're going out into the field responding to a disaster.
Within a lot of operations, there's a massive amount of data available, and so what we ought to be able to do is take that data and process it into information that allow people to make better decisions. And in particular, unstructured data like satellite imagery, UAV data, text and other reports. So what we do is we can upload that to our platform and allow the crowd to be able to take observations of that data. Those observations are then processed by the machine learning algorithms to be able to output actionable intelligence. And those machine learning algorithms can work out who are the most reliable workers for different features.
Is following the disaster that's occurred that we all know about. There's been some missing personnel reported in the area of Penthouse Sands. Okay, so area in detail is Penthouse Sands. Basically on this device here, if you just look in, what we've got is the crowdsource information that's helping us analyse the actual ground. So what we've got is the potential areas of shelter. So they're going to be our areas of interest mainly. As I pointed out earlier, these areas here and here are areas of habitation, as is this one here. So these aren't going to be our primary areas of interest. We know that there's no missing personnel in this area following communication to these areas. But what we do have is these two areas of interest, potential areas. This is our primary, because this one over here is still actually underwater, so we know that there's not going to be anyone actually surviving in this area anyway. More analysation of the ground we've got from the crowdsourcing is paths in the area, annotated by the sort of yellowy orange colour. So that's actually routes that people can take around the area. And then what we've got is ravines, or sort of steep sided areas. So potentially, or probably, people aren't going to be crossing these areas. So again, the shelter, so if we take the ravines back off, take the paths back off, the shelter is in this area here, the ravines are here. So we know that the people probably aren't going to be crossing east to west across this. We're over here at the moment. We're going to have to patrol around to the south and then up to the north to get to our area of interest.
So what has great potential with this project is the ability to speed up that decision making and that prioritisation, and to enable it to be focused. One of the key issues in a disaster is there's often huge amounts of potential information, but to be able to have actionable intelligence from that information is very difficult, and actionable intelligence that's rapid, so that it's timely and we're able to use that to respond and to be able to save life. the vision that we have, that we share for this project, is being able to stand up a platform very quickly, have a standby task force who can react to that information, and then be able to get them assessing that data quickly, so that whilst our teams are getting ready to go out, that information is being assessed by the crowd, comes back in, we use that for our decision making, our teams and other agencies respond to that, and then they will be sending data back as well, which then the crowds can be looking at, so you have a really nice feedback loop there. So for example, we could be using the drone to gather some footage when our pathfinders are out, and then the crowd could be looking at some of that drone footage and being able to identify features of interest with that. So you have a really nice mechanism where you're kind of increasing that level of information at each stage of assessment.